Hello, everybody. Good evening. Welcome to this live session on Massive Open Online course on solid fluid operations. I think by this time you have gone through several modules of this course. You have already gone through that. What the introduction part of that, solid fluid operation. What is the size reduction module, particle characteristics, even other modules like fluid flow through the porous media or particulate bed, even fluidization system, cross rotation, even separation module, different techniques of the separation that you have already gone through. Now you are almost coming to the end of this course. So the last, I think, 2-3 modules that you have to go through this. So do you have any queries for that? Okay, you can ask these questions. If suppose you are not understanding in any module, there is some a mistake in the module, even that equation you are not understanding or concept you are not understanding, that you can clarify here itself, or you can to a mail to me directly so that we can answer you. And we have discussed several modules earlier. And in the last 2 modules that we have discussed regarding that special modules, it is called that nano particles and its characteristics feature, and then absorption characteristics of the solid material, their principles, applications, even its isotherms and kinetics. There we have discussed several lectures on these 2 modules. I think there are 6 lectures that we have covered for these nanoparticle systems, and then adsorption principles and applications with their isotherms to be transferred from one page to the another page. So that absorption we have actually discussed that is an operation in which the certain components in a mixer are selectively transferred to insoluble materials which will be suspended or packed in a column. So this is basically absorption process. And under this absorption, you can say that some will be adsorption, some will be ion exchange, some method will be called chromatography. Now, as per your, that undergraduate, curriculum, we have discussed some extent about of that adsorption system, how that solid materials actually will be, acting, to, adsorb the certain components of a mixer, which is transferred to that solid surface with a certain mechanism. So those components that are selectively transferred, that will be called solutes, and the adsorbed solutes which are used, that is called sorbates. And the materials used for that sorbing the solutes are known as sorbents. Okay, so in that case, these sorbates, and by which those acting part for the separation of the unwanted material from a mixer. Okay, those will have several applications in industry. Some industrial applications that we are discussing that will be regarding what that gas purification, even liquid purification system there. And gas purification systems, there are some applications like removal of organics from vent streams, removal of sulfur dioxide from vent streams, removal of sulfur compounds from gas streams, removal of water vapor from air and other gaseous streams, removal of solvents and odors from air, removal of SOx, NOx, COx, you can say, from the natural gas, even gas bulk separation, hydrogen, oxygen, or moisture, ethanol, acetone, even vent streams, even ethane from the vent streams, normal paraffins, isoparaffins, aromatics, those gaseous bulk separations that is being done by this adsorption process. Even sometimes some components which are rich in water, in organic solutions, there sometimes it is required to remove that moisture or water from the organic solutions. There it is applicable that certain materials to be used to adsorb that water from the organic solution. In that case, some other applications like removal of organics from water, even removal of sulfur compounds from the organic solutions, even decolorization solutions, liquid bulk separation, normal paraffin, isoparaffin, normal paraffins, olefins, p-oxylene, even others like C8 aromatics, even other organic chemicals like fructose, dextrose, even polysaccharides. Those are to be separated from the bulk solution. So in that case, this adsorption mechanism to be used to separate those unwanted or separation of valuable components from the mixer. Even other than this adsorption, you can say that there is a similar mechanism, though it is called ion exchange or chromatography. You have described in the lecture in details there, like for the application of water softening, water demineralization, decolorization of sugar solution, recovery of uranium from acids, leach solutions, recovery of antibiotics and vitamins from fermentation broths, and chromatography is sometimes used to separate and analyze additives, vitamins, preservatives, proteins, and amino acids for quality control. Paper chromatography has been used as a purification and separation procedure for mixture of components. So these are basically the adsorption mechanism based on which you are going to separate those components. So whenever you are going to separate something, that whatever materials to be used, there should be certain suitability criteria for that solvent for industrial application. In that case, high selectivity to enable sharp separation that you have to consider, high capacity to minimize the amount of solvent needed, favorable kinetic and transport properties for repeat sorption. And also there you have to consider that whether these are free-flowing tendency for ease of filling or empty vessels or not, high resistance to fouling for long life or not, relativity of of capacity of being easily regenerate or not, also some chemical and thermal stability to be taken care, whether it has including extremely low solubility in the contacting fluid to preserve the amount of solvent and its properties. So these are some suitability criteria of solvent which is to be selected for the industrial application by this adsorption mechanism. So what is that adsorption? How you can define? So this is basically the process based on which the concentration of a solute, which may be molecules in a gas stream or a dissolved or a suspended substance in a liquid stream, attached on the surface of a solid by diffusion. So molecules or atoms or ions in a gas or liquid which will be diffused to the surface of the solid, where they bond with the solid surface or are held there by weak intermolecular forces. So this is the mechanism based on which that the absorption happens. Okay. So there uh, again, I am saying that if you do not understand those mechanisms, maybe it is some extent tougher for you to understand this absorption process at this level. But still, I discussed in the lecture very easy way and in the slide systematic way that I have given those definition and the mechanism with the figure and also that animation that you can easily understand this. It is required for you, those who are very intent to do that higher study or research in future. This mechanism you have to know for research in this particular field. So we can say that the process based on which that concentration of a solute, this solute may be molecules in a gas stream or dissolve or suspended some substances in the liquid stream, which can be separated by attaching those molecules or dissolve or substances on the surface of a solid by diffusion mechanism. I think diffusion, you have heard the diffusion earlier in mass transfer operation course in your UC course. I think you have heard this diffusion mechanism. There, Fick's law of diffusion, you have heard what is the diffusion coefficient, what is the Knudsen coefficient, whenever liquid or molecules will be diffused through the solid surface, then what is the diffusion coefficient, all those things that I think you have heard already. So here, basically, that adsorbed solute will be transported to the pores of the solid materials, and on the surface of that solid material to the pores, it will be attached on the surface of the solid, and based on which that absorption is. Now you will see that there will be a certain molecule which has that tendency to be adsorbed on the surface, otherwise other molecules will not be adsorbed, it will be separated from that mixture. In this case, the adsorbed solute, which is actually attached on the surface, will be called that adsorbate, and the solid which is being used for that separation of two solid material or substance or molecules on the surface, it is called adsorbent. Okay. So to achieve, you will see that a very large surface area for adsorption per unit volume, highly porous solid adsorbents with small diameter interconnected pores are used. So in that case, adsorbent which are to be used, there should be a huge surface area, so that maximum amount of molecules can be attached on the surface. So to get that very large surface area, you have to have the size of the particles which are being used or materials which are being used for adsorption. That should be very finer or smaller, even micro to nano. Okay, so highly porous solid adsorbents with small diameter, which is interconnected pores that are being used for that adsorption process to achieve a very large surface area for adsorption per unit volume. Now you'll see that the porous structure can account for up to 50% of the volume of the material. And during that adsorption, the solid adsorbent becomes saturated or nearly saturated with the adsorbate. And in that case, to recover the adsorbate, and if you allow the adsorbent to be reused, it should be generated by some mechanism by dissolving the dissolved substances. I think we have discussed that some example of that adsorption like biogas purification. There sometimes you need to separate that methane gases from the mixture of methane, nitrogen, oxygen, even moisture, hydrogen sulfide, carbon dioxide, etc. So in that case, you have to separate methane gas by suitable, adsorbing or material or adsorbent. Especially these carbon molecular ships are being used for separation of that, methane gas from those mixture of biogas, like mixture of methane, nitrogen, oxygen, hydrogen sulfide, and carbon dioxide. So in that case, this adsorption process is very, suitable for separation of these gaseous components. Now, in this case, that how then this adsorption happens? What is the mechanism? See that the molecules that is present in the interior of the adsorbent are completely that will be surrounded by other molecules on all sides, and hence intermolecular forces of attraction are exactly exerted by equally in all directions. So in that case, the molecule at the surface will be surrounded by large number of molecules. And you'll see that uh, there should be a certain, unbalanced, where you'll see that inward forces of attraction on the surface of adsorbent, they have the property to attract and retain the molecules of the gas or solute on the surface. So based on that, unbalanced forces, inward forces of attraction on the surface of adsorbent, the, whether these materials to be, attract or retain the molecules of gas or solute on their surface, that depends. So what type of materials to be used? That is very important to select. Now, in this case, some important points that you have to remember that whenever you are going to adsorb something by the solid surface, it's called adsorption, which will be exothermic process. And during adsorption process, you will see that the residual forces on the surface of the adsorbent that will be decreases. It means that surface energy decreases. And this decrease in the form of heat is called the heat of adsorption. And this heat of adsorption is defined that what will be the amount of heat that will be involved when 1 mole of any gas is adsorbed on a solid adsorbent surface. This will be called heat of adsorption or enthalpy of adsorption. And this enthalpy of adsorption will be always negative because it's an exothermic process. Now, question that what are the major types of that adsorbent I can use for that adsorption of different molecules. In this case, it depends on what type of molecules you are going to separate. What are the materials that will be, has capacity to that attraction of those molecules on the surface. So major types of adsorbents we have discussed there. Some will be, activated alumina, silica gel, activated carbon, molecular sheet carbon, molecular sheet zeolites, clay, polymers, and resins. So these are the common name of that, major types of, adsorbents. Now, each of these adsorbent material has some characteristics such as it has some porosity, pore structure, nature of its absorbing surfaces. Pore size are also classified into 3 ranges. Some will be macroporous, some will be mesoporous, some will be microporous. So that depends on diameters, whether it is in excess of 50 nanometer or not, that will be called macropores. Some will be diameters in range of 2 to 50 nanometer, it will be called mesopores. Even some will be diameter in smaller than 2 nanometer, it will be called micro, So here, in this way that, each adsorbent materials can be classified based on its size. Some typical application of different types of adsorbent also we have discussed in the lecture, like activated alumina. It has that, capacity to, drying of gases by, adsorbing moisture. Even for refrigerants, organic solvents, transformer oils, for that drying, it is generally being used. Even desiccant in packings and double glazing, this activated alumina are being used. Even you will see that dew point control of natural gas. For that, these activated alumina are being used. Okay. So this is these are some applications of this activated aluminum. Even silica gel, I think you have heard the name silica gel. Is that it is generally being used for that moisture removal from the atmosphere. You'll see that that drying of gases sometimes is being used. Even removal of hydrochloric acid vapor from the hydrogen gas, even removal of chlorine in alkylation process there. These are being used for separation of those components. Some other adsorbent like activated carbon, molecular shift carbons. This adsorbent has several applications like water purification, cleanup of nuclear off gases, nitrogen from air, separation of hydrogen from synthesis gas, even ethane from a mixture of methane and hydrogen gas, even vinyl chloride monomer separation from the air and its mixture, removal of odors from gases, even recovery of solvent vapors from the mixture, removal of SOx and NOx from the effluent gases. Even you will see that purification of helium, this molecular shift carbon or activated carbons are widely used. And then some other commercial adsorbents, that like molecular shift zeolites. This is widely used in removal of or separation of oxygen from the air, drying of gases, removing water from azeotrophs, even sweetening sour gases and liquids, even purification of hydrogen, removal of acetylene, propane, and butane from the air, even separation of xylenes and ethyl benzenes. These molecular shift zeolites are widely used. Even you'll see that in pollution control system, you'll see that they are suggesting to remove that mercury vapor, NOx or SOx by these molecular shift zeolites. Even recovery of fructose from the corn syrup, these molecular shift zeolites are being used. Some other type of adsorbents like polymer and resins. These are also used like that water purification of steroids, amino acids, even separation of fatty acids from water and toluene. Even you can say removal of organics from the hydrogen peroxide, even recovery of proteins, enzymes, separation of aromatics from aliphatic like this. And also, cheaper things that, sometimes, adsorbent like clay. These are being used for treatment of edible soils, removal of organic pigments, refining of mineral oils, removal of polychlorinated, biphenyls. These are, processed by removing those components by this adsorbent clay. So these are different, adsorbents materials which are being commonly used. So anybody has any questions on this? Please, write in the chat box that if you have any doubt here itself that we can clarify here, please write here. Or if you have any other doubt that you can, write to the forum or direct email to me so that I can, clarify those doubts. So what we are discussing that the adsorption, what are the different type of adsorption means process adsorption process, you can say. Some will be physical adsorption, some will be chemical absorption. What is that? In physical absorption and or chemical absorption, this basically depends on that, forces between the adsorbent and adsorbate. In physical adsorption, you see that the individuality of the adsorbate and the adsorbent are preserved there. And in that case, the adsorption occurs when the intermolecular attractive forces between molecules of the solid adsorbent and the gas are greater than those between molecules of the gas itself. So these are actual physical adsorption. Now this occurs quickly through mono or multimolecular or you can say unimolecular layer thickness. So this is called physical adsorption. So this occurs when the intermolecular attractive forces between molecules of the solid adsorbent and the gas are greater than those between molecules of the gas itself. Then you can say there will be a physical adsorption. Whereas in chemisorption, there is a transfer of, sharing of electron or breakage of the adsorbate into atoms or radicals, which are bound separately. And chemisorption involves the formation of chemical bonds between the adsorbate and adsorbent. Chemisorption from a gas generally takes place only at temperatures greater than 200 degrees Celsius, and maybe a slow or irreversible. Okay. So this is the some classification of that physical adsorption and chemisorption that you can identify based on this classification. Even you will see that sometimes that heat of physical adsorption is in the same order of magnitude as the heat of condensation, while the heat of chemisorption is of the same order as the of the corresponding that heat of vaporization. Now, physical adsorption will occur under suitable temperature pressure condition in any gas solid system, whereas chemisorption takes place only if the gas is capable of forming a chemical bond with the surface. This is the difference. A physically adsorbed molecule can be removed unchanged at a reduced pressure at the same temperature, whereas the removal of the chemisorphed layer is far more difficult. And one of the important points here that the physical adsorption can involve the formation of multimolecular layers, whereas chemisorption is always completed by the formation of a monolayer. So this you have to remember. And also physical adsorption generally happens instantaneously, although there is a diffusion into porous adsorbent that may be time consuming, whereas chemisorption, you will see that it will happen though may be instantaneous, generally requires activation energy. And there, of course, you will see that some other factors that will be affecting on the adsorption process. Because their adsorption usually takes place with the evaluation of heat. Okay, and also in the case of gas, you can say adsorption of a gas is followed by a decrease in volume. So in that case, the effect of nature of adsorbent and adsorbate will be the most important point there. In that case, the amount of the gas which is being adsorbed, that depends upon the nature of the adsorbent and the gas which is called adsorbate, which is to be adsorbed. And effect of surface area, of course, important. You will get that larger extent of that adsorption with a large surface area of the adsorbent under the given condition of temperature and pressure. And at temperature, you will see that according to Lars Atelier's principles, you will see if you decrease in temperature, that you will see adsorption will increase and vice versa. And as per also that Lars Atelier's principles, that if you consider the pressure effect, the magnitude of adsorption increases with the increase in pressure and vice versa. Okay. So these are the different factors which affect on this adsorption process. Now in industrial, you will see that for large scale operation, there are several equipments, those are being used for this adsorption process. You'll see adsorption equipment like star tank, even fixed bed, moving bed reactor, desorption and regeneration system. Okay, so there I think we have discussed in the lecture. We have given some, a picture also, those different types of, equipment for adsorption. And steer tank, slurry adsorption system. In that case, in the steer tank slurry operation, a base of liquid is to be added to the powdered adsorbent, such as activated carbon, you can say, in an agitated vessel to form a slurry. And also the main application is for that removal of very small amounts of dissolved and relatively large molecules, such as coloring agents from the water. This is stereotypic slurry adsorption systems. And in that case, some hydrodynamic characteristics to be considered, like the required residence time of the operation is mainly determined by how fast equilibrium is approached, or coming to that equilibrium point based on which that adsorption can be assessed. So in that case, required residence time of the operation is important factor. Also, you'll see that generally the spent adsorbent is removed from the slurry by filtration or sedimentation, and then to be discarded if it is not being further used. For large scale operation, multiple batch or cross flow or counter current mode can be used. Okay. So, do you have any query? Please, can you please write to that at box. Otherwise, if you have any other queries, you can write to the forum, or you can do the mail directly to me. If you have any doubt, then we will discuss. Okay, yeah. So anybody else? Anybody? Do you have any doubt? So please go through these, different, lectures, and try to understand those lectures. And if you have any doubt, you can ask. And also, please go through that, assignment questions that is provided to you, and try to submit that assignment regularly. And also, for practice, do that assignment questions repeatedly, and it will be helpful for your final, examination. And also, whatever problem example, or short problem that is given in the slides, please go through those problems. With solution also it is given. Please go through those solution also. It will be very helpful for your examination. So I think there is no doubt here. Nobody is has any queries in this live session. So I may wind up here. Further, I'm saying that if you have any doubt, then you can write to me. So thank you for your attention. Okay. Have a nice day, and also wish you all the best for your coming examination. And I think you have enjoyed this course, and in future it will be very helpful for further understanding of this chemical engineering process. Thank you.